Welcome back to day 4. I'm Adhiraj, and this is the OpenClaw bootcamp. Yesterday, you met every model provider that OpenClaw supports. You installed Ollama, ran a local model, compared cloud versus local, and built the mental framework for which model fits which job. That was the knowledge layer. Today, we turn that knowledge into money saved. We're talking about the difference between a $70 monthly bill and a $17 one, doing the exact same work with the same agent, same tasks, and same quality where it matters. Just smarter configuration. Cost optimization is not about being cheap, it's about being intentional. Every token your agent sends costs something, and most people are paying 5 to 10 times more than they need to because they haven't thought about where those tokens are going. That will change by the end of today. We start with a core concept, two-tier processing, using a cheap model for the background work, and a premium model for the things that actually need premium intelligence. Then we dig into the heartbeat math, because that's where most of the money goes, and most people don't realize it. After that, we tackle prompt bloat. Your system prompts and memory files are silently inflating every single API call, and we look at how to prune them. Then spending limits and monitoring, because even the best optimization doesn't help if you don't have the guardrails. We close with prompt caching, which is a genuinely powerful feature that most people don't know exists, and a final checklist that ties everything together. There's homework at the end that will actually save you money today. All right, so 3 things you're going to walk away with. First, a dual model configuration where your agent automatically uses cheap models for routine tasks and premium models for the conversations that matter. This is the single biggest cost lever, and we're going to set it up today. Second, a concrete understanding of exactly what you're spending and where. Not a vague sense that AI costs money, but specific numbers tied to specific behaviors in your configuration. Third, the ability to cut your monthly bill by 70% or more. That number sounds aggressive, but it's real. Most of the savings comes from one insight. Your heartbeat is probably running on a model that's 10 times more expensive than it needs to be. Quick foundation check. So on day 3, you learn the full model landscape. Claude Opus 4.6, $5 input, 25 output per million tokens. Sonnet 4.6 at 3 and 15. Haiku 4.5 at 1 and 5. 4.0 Mini at 15 cents and 60 cents. And local models through Ollama at 0. You install Ollama, pull Ollama 3.2, and send your first message through a model running entirely on your own hardware. You also set a spending limit with your API provider, which is going to be important context for what we're going to do today. The key insight from day 3 that carries forward is that model selection is the single largest variable in your monthly cost. Today, we're going to operationalize that insight. So here's what an unoptimized OpenClaw deployment actually costs. Take a typical setup. So Claude Opus 4.6 as your only model, you have the heartbeat running every 30 minutes. That's 48 heartbeat cycles every day. Each cycle uses roughly 1,000 tokens for the prompt and 500 tokens for the response. Now let's do the arithmetic. Input cost is 48 cycles times 1,000 tokens times $5 per million. That's 24 cents per day on input. Output cost is 48 cycles times 500 tokens times $25 per million. That's 60 cents per day on output. Total comes to 84 cents per day just for the heartbeat. Over a month, that's $25.25, and that's before you've even asked your agent a single question. If you add an interactive use, let's say 20 messages a day, averaging 2,000 tokens each, and you're looking at another $45 to $50 a month. Total lands around $70, and most of that is going to background tasks that you don't need to front your model for. That's the problem. And now let's fix it. Before we optimize, you need to understand what you're actually paying for, because tokens is an abstraction that hides important details. Every API call has 2 costs. The input tokens are what you send, so that's your system prompt, the conversation history, any memory context, and your actual message. The output tokens are what your model gets back. So output tokens are always more expensive, typically 3 to 5 times the input price. Your system prompt and memory context gets sent with every single request. If your sole markdown file is 2,000 tokens and your memory context adds another 1,000, that's 3,000 input tokens before the model even sees what you're asking. For a heartbeat running 48 times a day, that's 144,000 overhead tokens per day that have nothing to do with the actual monitoring task. And this is why prompt efficiency matters so much for agents. In a normal chatbot conversation, the system prompt is rounding error, but in an agent running automated cycles every 30 minutes, it's the main cost driver. The idea is simple. Your agent has 2 types of work: background automation that runs on a schedule, and interactive conversations where you're actively talking to it. These have completely different quality requirements, and paying the same rate for both is like taking a limousine to your mailbox. For the heartbeat and background tasks, you want to use a cheap model, something like Claude Haiku 4.5 at $1 input, $5 output, or 4.0 Mini at 15 cents and 60 cents. These models handle structured monitoring tasks like checking server status, scanning RSS feeds, reviewing calendar changes with more than enough capability. For interactive conversations, like the ones where you need the model to actually think carefully, you want to use Claude Opus 4.6 or Sonnet 4.6. The premium price buys you premium reasoning, and for these tasks, it's worth every cent. Now, the math is pretty dramatic here. The $25 monthly heartbeat cost on Opus drops to about $5.04 on Haiku. With the same checks, the same frequency, you get 80% savings. If you add in the interactive savings from using Sonnet instead of Opus for routine conversations, and then you're looking at a total bill that's a fraction of what you started with. Let's go ahead and set this up. So open up your config file at .openclaw/openclaw.json. Under agents, defaults, and model, you already have the primary key from day 2 setup. We're adding a secondary key right next to it. Your primary stays as your premium model, something like Claude Opus 4.6 or that Sonnet 4.6, and your secondary becomes a cheap model like Claude Haiku 4.5 or 4.0 Mini. So the config looks like this, right? Under agents, defaults, model, you have primary set to your premium model, and then secondary set to your budget model. OpenClaw will route heartbeat and background tasks to the secondary model and interactive conversations to the primary. You want to save the file and restart the gateway. From this moment, every heartbeat cycle uses your cheap model, and every time you message your agent directly, it can respond with a premium one. With just one config change, you've already saved a ton of money. Now let's put real numbers to this so you can see exactly what the 2-tier strategy saves you. For a 30-minute heartbeat cycle, that's 48 calls per day. Assuming 1,000 input tokens and 500 output tokens per call, with Haiku at 1 and 5 per million tokens, that's an 80% reduction from just switching the heartbeat model. And the quality difference for something like check if my server is responding or scan my RSS feeds for keywords is negligible. These are structured, repetitive tasks, and Haiku can handle them perfectly. If you extend to a 60-minute heartbeat cycle, which is pretty sufficient for most monitoring, you cut the Haiku cost in half, down to about $2.52 a month for all your background automation. That's pretty much free. Here is the exact config for adjusting your heartbeat interval. In OpenClaw.json, under the agents, defaults, and heartbeat, set the every field to your desired interval. The format is a number followed by a unit, so 30M for 30 minutes, 60M for 60 minutes, and 2H for 2 hours. The default from day 2 setup was 30 minutes, but for most users, 60 minutes is the sweet spot. You'll still get timely monitoring and your agent checks everything once an hour, but you've cut your heartbeat API costs in half. Now think about what your heartbeat is actually monitoring. If it's server uptime, an hour between checks is fine. It's RSS feeds, news doesn't become stale in 30 minutes. It's calendar changes, your meetings aren't moving around that fast. Be honest about what frequency you actually need. Most people who run 30-minute heartbeats do it because that was the default, not because their use case demands it. Here's a cost driver that's completely invisible until you look for it. I'm talking about prompt bloat. Every time your agent makes an API call, it sends your full system prompt, the relevant memory context, and conversation history. If your soul markdown file has 3,000 tokens over time, as you've added those personality notes, instructions, and preferences, that's 3,000 tokens of input on every single call. For 48 heartbeat cycles a day, that's 144,000 extra input tokens daily. On Opus, that overhead alone costs 72 cents per day or $21.60 per month, just from a bloated system prompt. On Haiku, it's 14 cents a day or $4.32 a month, still significant. Now the fix is simple. Audit your soul markdown file periodically. Remove instructions that your agent has already internalized into its memory. You want to cut those verbose explanations down to concise directives. Every 100 tokens you trim is going to save you real money every day, compounded across every automated cycle. Think of it like this. Your soul.md is a tax on every API call, so you want to keep it as lean as possible. Same principle applies to your agent's memory files. OpenClaw's memory system accumulates context over time. That's by design, and it's how your agent gets smarter about your preferences and situation. But old, outdated memory entries still get loaded as context, and they cost tokens on every call. You want to run OpenClaw memory stats to see how much memory context your agent is carrying. If it's grown beyond a few thousand tokens, it's time to prune. You want to look for duplicate entries where the agent has learned the same thing twice. Also, you want to look for outdated information that's no longer relevant or overly verbose entries that could be condensed, a memory entry that says a user prefers responses in bullet points format with technical details included and examples where possible, especially for code-related questions, can become just prefers bullet points, technical detail, and code examples. It's the same information, but much fewer tokens. Lean memory means faster responses and lower costs on every single interaction, whether automated or manual. Even with all the optimization in the world, you still need guardrails. You want to set spending limits before your agent runs unattended. On Anthropic's console, you want to set a monthly usage limit. When you hit it, the API calls will stop. Simple and pretty effective. You start it at $10 to $20 while you're learning. On OpenAI's platform, you can set a monthly spend threshold, and they'll email you when you cross it. OpenAI's spend limits are alert only. They do not guarantee a hard stop on API usage. Users have been charged well over their set thresholds. So don't rely on OpenAI's limit as a safety net the way that you can with Anthropic's hard cap. You want to monitor your usage actively and set the threshold at $10 to $15 initially so you can catch runway usage early. Both providers also offer per project API keys with individual limits. If you're running multiple agents or experiments, create separate keys so one runway process can't eat the budget for everything else. Let's put the full picture in one place so you can make informed decisions. Cloud Opus 4.6 runs $5 input, $25 output. It's the best complex reasoning available. You want to use it for high-value interactive tasks. Sonnet 4.6 is $3 input, $15 output, strong all around, and the best default for daily interactive use. Haiku 4.5 comes in at $1 input, $5 output. Excellent for structured automation. This is your heartbeat model. GPT-4o Mini is 15 cents input, 60 cents output. It's the budget king. It's even cheaper than Haiku for background tasks. Gemini 2.5 Flash Lite is 10 cents input, 40 cents output. It's Google's ultra cheap option, and it's worth testing for high volume automation. And then local, as we discussed yesterday, via Ollama is $0. It's free forever. Now the trade-off is capability, but for heartbeat tasks, a good local model is more than sufficient. Llama 3.2 comes in at 1B and 3B text models, plus 11 billion and 90 billion vision variants. The 3B is what you get with the Llama Pull, Llama 3.2, and it's pretty capable for its size. The pattern is clear. For background automation, you have options that are 10 to 50 times cheaper than frontier models, with negligible quality difference for structured tasks. Let me show you what all of this looks like in practice with a real before and after comparison. Before optimization, let's say you're running everything on Opus 4.6. 30-minute heartbeat, bloated prompts, the monthly cost comes to $70.80. That breaks down to about $25 in heartbeat costs and $45 in interactive use and significant overhead from prompt bloat. Now let's say you watched day 4, you took the tips from today and you implemented it. After optimization, you're using Haiku for the heartbeat, Sonnet for the interactive use, with 60-minute heartbeat intervals, a pruned soul markdown file, and memory. Your monthly cost drops to $17. Heartbeat falls to under $3. Your interactive use dropped because Sonnet is cheaper than Opus, and the per call overhead shrank because you trimmed your prompts. That's a 76% reduction with the same agent and same tasks, and same quality where it actually matters. You just stop paying premium prices for commodity work. Optimization isn't a one-time thing. You need visibility into what you're spending on an ongoing basis. OpenClaw gives you 2 tools for this. The dashboard has a cost tab that shows you your token usage broken down by model, by task type, and by time period. You want to check it weekly and look for patterns. Is one particular heartbeat task consuming disproportionate tokens? Is your memory context growing over time? From the command line, you can also run OpenClaw stats with a this month flag for a quick summary of your current month's usage. It's going to show you the total tokens consumed, the estimated cost by provider, and a breakdown of heartbeat versus interactive usage. You can then also set up Telegram cost alerts so your agent notifies you when you've hit certain spending thresholds. A message that says that you've used 50% of your monthly budget at mid-month is a lot better than a surprise bill at the end. Build a habit of checking your costs weekly for the first month. After that, once you understand your patterns, monthly is fine, but that first month is when you want to catch any misconfiguration or unexpected usage. Now, this is an advanced optimization and it can really reduce your costs if your agent is making repeated calls with similar prompts. Prompt caching lets the API provider store your system prompt and reuse it across calls instead of reprocessing it every time. Since your system prompt is identical on every heartbeat cycle, this is a perfect fit for agent workloads. Anthropic offers a 90% discount on cached input tokens. That's massive, right? You do need to add cache control markers To tell the API what to cache, there are two TTL tiers. You have a 5-minute cache that costs 1.25 times the base input price to write, and a 1-hour cache that costs 2 times the base input price to write. For heartbeat cycles, the 1-hour TTL is the right call. You pay more upfront to create the cache entry, but every heartbeat read within the hour gets the 90% discount. Over 48 cycles a day, the math is overwhelmingly in your favor. OpenAI handles caching differently. It's automatic with no markers needed. Any prompt prefix that's longer than 1024 tokens is going to get cached automatically. The discount is 50% on cache tokens, which is less aggressive than Anthropic's 90%, but requires absolutely zero configuration on your end. If your system prompt is 2000 tokens and you're running 48 heartbeat cycles a day, caching can save you the equivalent of tens of thousands of input tokens per day. On Opus pricing, that can be a lot of money. Here is your action checklist. Do all of these and you'll hit that 70% plus reduction. First, add a secondary model. Set your heartbeat to use Haiku or 4.0 Mini. That is the single biggest lever. Second, you want to extend heartbeat to 60 minutes. So change the every field in your heartbeat config from 30M to 60M. It's half the calls, thus half the cost. Third, you want to prune that soul markdown file. Cut it down to the essential directives only. Every token you remove is going to save money on every call. Fourth, you want to run OpenClaw memory stats and cleanup. Remove those duplicates, condense your verbose entries, and delete that outdated information. Fifth, you want to set spending limits on your API provider, $10 to $20 to start. Raise it when you understand the patterns. Sixth, you want to use the dashboard cost tab and check it weekly. Knowledge is power here. You can't optimize what you don't measure. And so that's it. There's 6 concrete actions. None of them reduce the quality of your agent's output for the tasks that actually matter. All of them reduce your bill. 4 things before day 5. First up, you want to configure the dual model setup. Add the secondary model key to your config, set the primary to your premium model, and the secondary to Haiku or 4.0 Mini. Restart the gateway and verify that both models are being used by checking the dashboard. Next, you want to change your heartbeat interval to 60 minutes. Update the heartbeat config to use every 60M. Confirm that it's working by watching the dashboard for a new cycle timing. Then audit your soul.md and your memory. Read through that soul markdown file and trim anything verbose or redundant. Run OpenClaw memory stats and prune the old entries. Then note how many tokens you've saved. Finally, you want to check your spending so far, so run OpenClaw stats this month and look at your current usage. Set a spending limit if you haven't already, and screenshot your current costs so you can compare after a week of optimized configuration. The goal is that by day 5, your agent is running the optimized 2-tier setup, and you have baseline cost data to measure against. That's day 4. So let's think about the progression for a sec. Day 1 was concepts, day 2 was installation, 3 was understanding the models, today was making them work for you economically. You now have an agent that's smart about how it spends, cheap model for the routine stuff, premium model for the real conversations with lean prompts, sensible monitoring intervals, and guardrails in place. The cost difference between an unoptimized and optimized OpenClaw deployment is pretty insane. We went from $70 to $17, and that's the difference between this is an expensive hobby and this costs less than Netflix. On day 5, we shift gears entirely. We're going deep on the channels. So Telegram, WhatsApp, Discord, iMessage, Slack, and the built-in web chat. Your agent is running an optimized. Now it needs to live where you already are. We connect every surface and cover security, formatting differences, and which channel to reach for in which situation, and I'll see you there.